Happy Monday, everybody. How's it going?
Hello, hello.
It's going well. Good to see you, Joe. Good to see you, Juan.
Yeah,
Hello, Joe. Hello, Matt. This is a great way to start my Monday. Big coffee and chat about data and chat about
indeed.
modeling and knowledge. Here we go.
Got some interesting Mondays. Yes, we do.
I mean,
too.
don't we all? Come on, let's be honest.
Yeah, it's true. It's very true. Awesome. Juan, for people who don't know who you are, do you want to give a quick intro?
Yeah. Hi, everybody. My name is Juan Sequeda. I'm the principal scientist at data.world. I've been in the adult data, the data knowledge space for like 15 years. I started as an academic. I did my PhD at UT Austin in computer science. So doing a lot of data knowledge and semantics and modeling stuff. Done startups, sold my startup to data.world a couple of years ago. That's why I'm here. So yeah, I carry two hats, my academic hat and then also my business hat, and trying to bridge these two worlds. So I can be religious. I know we'll get into that and understand where that comes from, but bridging with the real world, we got to be pragmatic. So I think that's going to be one of the themes of us talking today.
How would you describe the contrast between the two worlds, Juan? Because, of course, I also come from both worlds.
That's true, man.
Yeah,
Yeah.
I was going to say.
So it's basically theory and practice. At the end of the day, if you look at the scientific method, right, you're making observations of the real world, right? I mean, so you're observing a group, right? You're looking under a microscope or something. You make observations of the real world, and from that you come up with a theory, and you have to find a hypothesis and stuff. And then you I want to find evidence if this is true or not, and you create your experiments. And the experiments are evidence to support that theory that you have. And if that's true, you come and then you try to convince your peers about that. That's why we have a peer review process. But at the end of the day, it is really true if you bring it back to the real world and it applies. So all this to go say is you have the real world where you're observing, and you have the control world where you do your science and stuff. But to truly close the loop is that you have to say all that stuff that I did in my control world, I need to figure out if it actually can work in the real world without me even touching it. And a lot of science stays just in that control world, and somebody else needs to go translate that science back. So then you have translational science. But I think what I find really fun is to be able to kind of move between those two words. So I can observe what's going on, and then also go into the control world. But once I see it in the control world, wait, we made all these assumptions. Now let's bring it back into the real world and see if it works. And maybe we change the assumptions, and the problem gets easier or harder or whatever. So I think it's being able to kind of switch your hats around that. And a lot of the academics don't talk to the real world, and a lot of the real world, I say, has missed opportunities because they should be talking also to the smart people in academia.
Well, what's your thoughts on that, Matt? I mean, I think you come from the purest of pure math. So, what did you have any contact with the real world, or is it what's pure math like?
So the most contact you get with the real world, if you're in pure math, is teaching, right? And so it's very clear. I don't know what your experience was, Juan, but for us, we were typically teaching fairly introductory math classes, and our goal was, first of all, to help students fulfill requirements, and second, hopefully, to give them something that would be useful in their future, one way or the other. In terms of my academic experience itself, there was less contact with the real world, although there was some effort for career preparation, just with the understanding that not everyone is going to end up, teaching at a university in the long term. So, Yeah.
Speaking of the real world, we're here to talk about honest, no BS data modeling. So I think that to kind of tee this conversation, we've been noticing, I would say maybe some strong opinions about data modeling, specifically on LinkedIn. I think we're here to kind of cut through the BS and talk about pragmatic, practical data modeling, not something that's baked away and hidden from the real world. But let's get into it. What is no BS data modeling?
Well, first of all, is we can be religious about things. We can go off and say, well, you can go do these, you got to follow this approach, and if it's not this approach, it's wrong. So first of all, I think there is no right or wrong when it comes to data modeling, right? This is the last post I did. It's an art and a science. And I think it's an art and a science because humans are involved, and us humans are complicated, right? There is no one way of seeing things. And then there's a lot of things that we want to go optimize for, right? Are we optimizing for technical aspects, for storage? Are we optimizing it for how we're actually going to go compute queries? Are we optimizing it for the user experience of what type of end user who wants to be able to go consume that data? All of these are different types of ways of how we can go model things. And at the end of the day, you'll realize, wow, there's this piece of data and knowledge together that wants to be exposed in different ways depending on the requirements. That's it. I mean, there's no one way to go do this. There's no right or wrong way to go do it. I want to go through some examples, but I'm curious what you guys have to think about. What do you guys have to say about all this art and science when it comes to data modeling?
I just want to add to what you were saying, Juan, and that is also that data modeling represents organizations, right? And we all know that business organizations are complex and they're political and they're even kind of feudal sometimes. Then you also have relationships between businesses, with suppliers and with customers. All of that needs to be reflected in your data modeling. And so this is a very human problem. It's a very almost like sociological problem sometimes, as much as I hate to admit that.
So I think one of the issues that's been going on, in my opinion, is that we just focus so much on the data and we don't focus on what I've always been talking about, the knowledge, this knowledge first world that I've talked about. We had a previous session with you guys on this. Now, what happens is that data moves across an organization, but it moves without that context tied to it, without that semantics, that meaning tied to it. And I think this is something one of my colleagues and I work with, Aurel Asilla, who's at Amazon. We wrote our book together on designing knowledge graphs. He says it really great. That is, you want to be able, the data and the semantics need to move across together, because if they don't, then every system that's consuming that data is implementing their own semantics. And it's implementing semantics because, well, if it's implementing the correct semantics, because it's talking to the actual people who designed it originally, where that original source of data is coming in. But that stuff moves along, and then at some point, you have no control of what that data is. And if you don't have the semantics tied to that, which is the modeling, which is the contracts, the constraints, all that stuff, right? We're just now inventing new names for this stuff, right? These data contracts are just constraints that we're defining, right? So all these things need to go tied together. And because we're not putting them together, that's why we have that big freaking mess. Let's just keep doing the same thing over and over again, expecting different results.
Joe, I want to hear your thoughts. I know you have a lot of thoughts on this issue.
Well, I have so many thoughts. I'm writing a book on it, on data modeling right now. So, yeah, I mean, the more I dig into data modeling, and for full disclosure, I've also done data modeling for a while, so it's not like I'm some novice at this kind of stuff. But what I do agree with what you say, Juan, where there's it's art and science, and there's different approaches too, right? And so the frustrating thing is when I read a lot of these idiotic comments on LinkedIn and other places, they tend to be from a place of one use case, right? But ignoring all the other use cases like you described, where data has to kind of traverse from source systems to maybe a warehouse, a lake, or maybe it's in a stream in which none of these things apply, right? And the machine learning and so forth. I tend to take a step back and look at maybe a more holistic view of what modeling as a discipline, and an art versus one way to shoehorn everything in. Or I would say one modeling approach in which to shoehorn in all practices, right, whether they're related or not. And I think it's where the dichotomy of the discussion tends to kind of split off. Is there's a lot of I think camps that feel their approach is the only approach, regardless of whether or not it even applies or not. So I mean, it kind of reminds me of like hair metal bands that kind of feel like guitar solos are like appropriate in every single occasion of music, whether or not it really is, or whether regardless of the genre. And that's about as ridiculous as a lot of these conversations and people look right now.
So I'm going to make a statement. I wonder how controversial it is. Honest, no BS. All data modeling is just graphs. Think about it. You have all types of third normal forms. If you read I got all my textbooks here because I was looking at them before this. It's all about every table represents a concept, some entity in the world, right? You think about what's a star schema. You have a fact, and you have dimensions. All these dimensions themselves are things that are related to each other. Sixth normal form is basically the graph normal form, right? If you do sixth normal form, you're literally reproducing everything down to triples, to unary predicates and binary predicates. That's the definition of a graph. The data vault, all these things, hubs and satellites. Hubs and satellites, right? I mean, these are nodes and links, right? That's you're describing a graph. And an activity stream. You're just really going off and you're representing things as triples or maybe quads because you're providing more context. So going up to something that I just saw here in the chats that Sonny was saying, like, oh, modeling for warehouse application. Do you think modeling for warehouses applications and data consumption differently? I would say at the end of the day, it's all a graph. And then what you want is that it's some projections over that graph. That projection can be, I want a table of customers, and that one table represents the concept of a customer. Every single row is one customer, and it's going to have 200 fields in it, 200 attributes. Fine, that's what you want. Somebody else, I want to go have a star schema for these things, for the type of analytical queries. Fine, that's the projection that you want for a particular use case. So I think at the end of the day, if you look at it, this is all a graph. I think that's how we can kind of figure out what, start being a little bit more pragmatic about it. At the end of, also, when you go talk to the users, you go in front of a whiteboard, what the heck do you draw? Draw a graph.
Speak for yourself, man. Just kidding. No, but okay. So, Matt, I'm gonna appeal to your inner mathematician. Proof by contradiction. So let's find an example of where you wouldn't model something as a graph.
No, I mean, basically, I agree with Juan, and especially from the mathematical perspective, it's very appealing, right? This approach to data. And the thing I'll add too is that in terms of normalization, there's been a lot of, I would almost say, conflict between the two camps, like don't normalize, normalize. And I think the reality is that we generally want to land somewhere in between. So for example, third normal form does not allow any nested data. You're not allowed to have structs, arrays, all these modern constructs are not allowed. And yet there are places where that totally makes sense. There are places where it doesn't, but there are places where you want to actually embed data deeper inside a table where it's not going to be used across multiple places in an organization, right? And yet if it's going to be used across multiple domains in an organization, then it needs to set in a separate table and be a part of this bigger graph. That's kind of the way I see things. And that's where it's kind of an art and a craft, right? Like you have to drill down and say, okay, what actually makes sense in this context versus what is mathematically acceptable? Well, I don't know. What are your thoughts on this one? Like the normalization versus.
So I'm seeing questions about people's like, how would
I'm gonna bring up Roger's question, if you don't mind.
Yeah. So how do we do this in real life? So, okay. So again, let me continue being a little bit more controversial here. And this may be, I'll acknowledge that maybe a little bit of religious on my side, right? I come from the semantic web community, right? So 15 plus years ago, right, about how to represent semantics and data on the web. And it's all based on triples, on RDF. The RDF standard is for triples, subject, predicate, object. So that is the fundamental kind of piece of the building blocks of all knowledge. Because a triple is you have a unary predicate, right? And a binary predicate. So basically, if I say Juan is a person, that's equivalent to saying, oh, there is a predicate, or consider it a table with one column called person. And then every single cell there is that thing, which is Juan, for example. And then every single relationship is a binary predicate. Juan lives in Austin, right? So there's a lives in table, call it, which only has two columns, Juan and then Austin. That's it. You can represent everything in unary and binary predicates. I mean, this is, you go back to history of the knowledge representation. That's description logics from the 80s that realize that you can go represent things in here and it can be tractable when you're trying to go do some for different types of computational tasks. Now, having said that, is that the ideal way of storing and representing the data? Now we can come in and get debatable about it, because effectively I've gone to like the basic things for representing data and knowledge. It's almost like saying it is basically the assembly language of this. We went about everything to triples. Now, why is this annoying? Imagine I want to go say, find me all the people who live in Austin, who are between this age and between that. Every single triple is aligned with the query that you're doing. Gets kind of, I mean, now you start getting into like, oh, this can be annoying, right? This is the user experience of it. So then you can argue maybe that's not the way that that all types of users are supposed to be able to go query that, but it is a fundamental kind of the lowest common denominator. You can then take any type of data and turn it into triples, which is a fantastic thing if you're trying to integrate data. That's why I've always argued that the RDF data model is the ideal model to go integrate data. If you're going to go integrate data without thinking about RDF, I will bet that you're probably going to re-embed all the principles that are behind RDF, which is going to say, oh, I need to have key value pairs. Key value pair is the predicate and the object, and this thing is nested inside of a concept. You just put a triple in there. You put a graph, right? Now, another thing that's really important about this is to think about the identifiers. And I think this is something we talk about modeling and we don't talk about identifiers. Like this is a critical thing. If we think about identifiers from the beginning, a lot of our data integration problems can be kind of can quote unquote come for free, right? I'm not saying comes for free, but it gets much more easier. Now, going back to the original point by Roger, I would say that here's a controversial thing. store all your data as a graph, an RDF. Now, I'm not saying that that's the way you're going to then do all your analytical work. No, you would then make a projections over that stuff. And then you would move and make the copy of it. Yes, you would be copying data, right? But I think that's the balance you want to go do, because at the end of the day, you're having these, you have to store it physically somewhere. And I think having the identifiers is something very clear to be able to go start connecting data. So to wrap all this up is, yeah, why not think about storing the data in RDF, storing in a graph format, where you actually have identifiers that's going to help you do the connections. Now, that's a controversial statement, because not people will argue that, no, these graph databases aren't there for scale and so forth. And it's like, yeah, that's true. It's true. But I'm not saying to go do all your types of processing over that graph database. You'll make projections over these things. And I think there's still room for a lot of innovation here. And that's why knowledge graphs are ideal. I agree, Jake.
I like this idea. What do you think, Joe?
I mean, it's interesting. So, I mean, what you're proposing then is maybe using the knowledge graph as sort of an intermediate layer in some ways, or
this is it. Yeah. I think the knowledge graph is that intermediate layer, and it does not mean that it needs to be exposed to everybody that way. I mean, and so I think, but now we're going too much into the tech. I really want to kind of go up into the more talk about the modeling side. But I mean, this is just my background and where I've dedicated over the decade of my career, and I bet my career on this. So that's why I'm really pushing it, because otherwise I think I've been wasting a lot of my career.
Well, let me just ask is a couple of questions here we can get out of the fairly, I would say, detailed questions, but let's get these and we can go kind of zoom back up. So Roger, I kind of asked a follow-up question. Why choose RDF over property graph? I'm asking because personally, I find property graphs much more user-friendly to work with versus using an RDF.
Yeah, that's fine. So first of all, there's always kind of this debate about RDF and property graph. I think this should not be a debate. At the end of the day, everything's a graph. And I think you look at what Amazon is doing with their one graph project, it's going to be the same. So it's, again, a projection over that. So you want to have a property graph version of it and do it over RDF, fine. That's what's going to happen. A couple of people are already doing it today. A couple of vendors are doing it today. It's going to happen tomorrow. Having this discussion of an RDF and property graph is a waste of time.
Cool. John Cook asks, hey, shout out to John Cook. Hope you're doing okay.
John.
Yeah, so what about storing raw and overlaying graph per use case as your projections?
Excellent point. And that's actually that was my PhD, was how do I overlay graphs over it? Because I would say, hey, you're not going to go move all your data to graph. So my PhD was about how do I define these semantic models, these ontologies, these graph models, and map them to specifically to relational databases. And that was using a lot of virtualization, to run queries over that graph and then virtualize it, which was virtualized, and then rewrite it to the SQL, and then using all the optimizations. So yes, that's the next approach. Has it raw where it can optimize for some sort of storage. What happens there is that in that raw may not have clear semantics. So that semantic layer, now that's a good way of getting into the modeling. That model right there is what's providing the semantics. And then you need to connect that semantic model to the raw. And those are the mappings of transformations. That's how you're providing the semantics to that raw data. And then you can say, well, let me go query that in terms of that semantic model. Maybe you'll realize that if performance is not great, what is one of the best ways of optimizing queries? You materialize it. So then that's why you then would end up materializing it into a graph, where you'll have, hey, every node that has all these properties ends up being a table with all the columns, right? I mean, a table with columns, that's a node with all the particular edges associated to that node right there.
What are your thoughts, Joe, on what role will graphs play in your data modeling book as it's structured right now?
It'll be in there. I'm not going to give too much away. But
okay, yeah, that totally makes sense.
Yeah, it's like, so I'm intentionally trying to avoid them at all costs in the book. It'll be a pretty crappy book as a result. But actually, John Gorman has a good question here. Yes, since knowledge graphs, property graphs, and tables are storing the same quote stuff semantically, isn't a hybrid architecture possible and practical for analytics?
Yes.
Cool. Easy answer. Okay.
Of course. I mean, this is now being pragmatic, right? The religious in me would say, no, everything has to be stored in a graph table. It's like, no, just find the hybrid thing that will work best for you.
It's my impression is people are talking around each other in a lot of cases. They're shouting past each other. Like you're in the graph camp very, very solidly, I would say. But there's people that are I wouldn't say they're not in the graph camp, but they just tend to express their views on modeling in different ways. And I think those conversations do tend to be ones where people are shouting past each other. Why do you think that is? Why do you think it's not like any of these concepts are new, right? A lot of these concepts are decades old, older than us, probably all put together, which is pretty old.
I have it. So this is my book. This is my book, and I have
Nice.
it here.
Hold up the
It
cover a
says-
bit more.
Sorry. Oh, here's the cover. Designing and
Building
building
knowledge graphs. Okay, awesome.
Right. By the way, Aura is one of the. He's a designer of RDF back there. The first version of RDF in 1998. So,
Nice.
I say it here. The limits of my language means the limits of my world. Right. That's Ludwig Wittgenstein. Very much applies here. SQL is the language, and thus understanding that there are other ways to do things, ways not even possible with SQL, makes it hard for many people to get started with graphs or to understand how they could use graphs to benefit their advantage. This can make it hard to adopt graphs. All this to say is we've just been used to doing things in tables, and tables are our life. So it's just change is hard. But again, if I tell people just be critical about it, if you do if you do ER modeling, right? You do all these data volume. You end up drawing a graph. You go start talking to users, and they're going to start thinking, hey, this is bubbles and lines, right? That's what they're drawing out. It's a graph. Now, the other thing about a graph is that their logic, your conceptual model, your logical model, your physical model, those all get combined into one. There is no difference between a physical, maybe underneath the hood, how everything is stored on disk or whatever, right? But at the end, it's like, I'm not like, drawing the picture and then I'm translating it to go add some of the data types and then, the exact same syntax that needs to be done for this database. Like, no, all that stuff is just all one. And I think that if you start to get that mindset, that kind of lowers the barrier, because like, there's less amount of work I need to go do. The same way I draw things on the whiteboard is the way how I query things, is the way how things are being stored.
You look like you want to say something? No?
Oh, no. I just think this is a very interesting way to think about things. Yeah, especially if you can really link the concept of graphs to business domains for people working in pragmatic contexts. It's a very powerful idea. Obviously, we've all been using ER diagrams for a long time, but I think this seems like an abstraction that maybe is a little more powerful in terms of connecting users to the things they actually want to get done.
So to get very pragmatic about this, right? So I tell people, this is why I think the role of, I call it the knowledge scientist, or it's the former knowledge engineer, it's the data translator, whatever. It's the person who can be the bridge between the business side and the technical side. And then, and also from a social perspective, they're great at managing conversations. So I would say you go talk to somebody in a particular business line and you say, hey, how does your business work? Just tell it to me. And they'll start describing, let's start talking about it. And then you go to the whiteboard and you say, okay, so I'm hearing that there is a customer. So just draw customer, put a 9. Oh, so you say a customer here, then they place an order, right? And you're just kind of hearing the words that they say. You put the order and there's a relationship there. There's a line. Yep. And then I tell people, fill in the blank. A customer, blah, 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 order. What are the words that you use? And then you're like, no, please finish the sentence. John is a customer and he, blah, 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 a book, the book, which is place this order, whatever. So fill in the blank. That's how, those are the relationships. We start getting these words out. Keep doing this around the particular domain. Now you do that for one business line. And the end result is literally the whiteboard. Go to another business line and just go say, hey, how does your business work? And they're going to go see what words they go use. Don't say, oh, you're wrong. Just listen, right? This is what we call, again, the therapy session, right? Mm-hmm. Listen to this, right? Blah. And if they bring up, yeah, but those other folks, they use this other words, like, hey, just start making all these notes around it. Then go to a third one and go do this again, right? And then now you have 3 different versions of a model, which happens to be the graph. Now you start connecting and saying, hey, they're all using the same word customer, okay? All right, then we can figure out how to go merge these things. Oh, this stuff is contradictory. Then try to figure out how to go merge these 3 things into one. Then go back to that first one. Say, hey, I was talking to some other people. What does this look like? And they're like, I don't know what they'll say. Oh, yeah, that makes sense. Or no, I would not say this thing or use this other word or this, keep going through that stuff. And then after you share that kind of combine with each of those three people, then bring them together into the room and saying, hey, here are things that we couldn't agree on. By the way, like this is how you're describing your own business and how you were defining.
I was about to say, it sounds like you just drew an org chart.
Well, this is
and a process map. Yeah. So,
yes.
which is
And then this is when you understand the business processes behind it, right? And this is why I argue all the time, like the true data leaders are the ones who are going to cross that bridge and understand, not just work with the business, they're going to understand how the business works.
Shout out to JU. Says ER diagram is a graph. We actually had Jay on our show several months ago.
Hey,
he works a tiger graph. Yeah, he's awesome. But he echoed a lot of the points you had too. And Matt, I violently agree with these. But everything at the end of the day is a graph. I don't know.
No, for sure. No, Jay's a really good friend. Glad to see him here.
It's awesome.
So I think that's one of the stuff that goes in. Now, what does it actually mean? Then we get to the semantics of things. It's like, okay, now we have this bubble called the customer. So where is the customer data for you? Oh, so one person says the customer data is in this CRM system. And for somebody else, they say the customer data is in this other system. Well, that's now when you start getting into the mappings, these transforms, which are going to implement it in, right? We can't, I mean, you have different versions of it. That's fine. So now we know that, hey, if business line marketing is talking about customer, you know what their context is and what they care about and where that data comes from, right? And so this is that's that process that we need to go talking to people about it.
I like how you're framing this as a conversation, because I think so often we're in data modeling, like come into a business domain and we try to tell them how to think about things like, okay, this is our database theory. This is how we normally think about modeling. Here are normal forms, instead of asking them to frame it in terms of their own language. Because in general, the domain stakeholders understand these details a lot better than we, the database people, do.
Exactly. I mean, if we there's this other thing, like how do we know? There's some discussion seen in LinkedIn about it's hard to go define how we're providing ROI for our data teams. It's like, if you know how the business works, and you, of course, you know if you're providing value or not. And if you're saying, oh, we can't provide ROI value, but like that I call true bullshit, because it's like then what, you're such a magical thing that you receive money, you're not accountable to anybody? No, screw that. I'm sorry. That's ridiculous.
Well, to be fair, that did happen until recently.
Oh, that's why it's ridiculous.
I know.
And then this is why everybody's now saying, hey, where's the ROI? Well, no, I don't need to provide ROI. I'm like, screw you. Of course you need to go do. The freaking CEO needs to be accountable for everything they do. You think you don't need to go do that?
Right. Yeah, that's definitely true. It's interesting too, because I feel like a lot of the I always say repeatedly on the shows, I kind of, lately, especially everything's been, it's a pendulum between like rigor and speed, and we'll get into this in a second too, but it feels like the last 10 years have been about moving fast at the expense of rigor, at the expense of sometimes doing the basics like understanding your business and making data products that have ROI and all this stuff, because it's all about like, let's get the market fast, let's just take share. That came to a screeching halt recently. So now all of a sudden the pendulum swung the other way, and now it's about rigor. Now we have to start providing ROI and so forth. I don't know if you've seen similar things in your experience, data professional, but I'd love your insights into the notions of speed and rigor and trade-offs.
So you call it speed and rigor, and I call it efficiency and resilience.
Okay.
So we live in a world where you maximize being efficient. Right. So in this example, a couple of years ago, I think 2 years ago, at the beginning of the pandemic, Professor Moshe Vardi, right, one great living computer scientist, has this presentation on efficiency and resilience, what we can learn from the pandemic. I highly suggest you to go look efficiency, resilience, Moshe Vardi, and go find his YouTube videos about this. Why did we run out of toilet paper at the beginning of the pandemic? We had an efficient, just-in-time supply chain, but it was not resilient for something like this. The Suez Canal is extremely efficient, but you have one ship goes like this, and the entire economy of the world can go kaput, right? So it's not resilient about that. So we focus on being efficient and getting things now. What happens is that we're also being incentivized to be efficient. So somebody comes in and says, I need to ask this question right now. You go do your work and you answer the question. Done. Perfect. All right. You answered it. Next person comes along, I need a question. Well, you go do the work. You answer a question. Keep going on. So there is like a one-to-one mapping between the amount of work and the amount of questions that are being done. Now it's being very efficient, but now if we think about it, that amount of work, isn't that work being run? Isn't it being redundant? Maybe, right? Is it correct? I don't know. So if we in a resilient world, you would actually sit down and kind of organize, right? You slow down to speed up, and you say, well, what amount of work can I do to maximize much more kind of outcomes later on? So the example I was given is we need to have real-time. We need statistics, numbers about real-time users. Go do my work. Go create my transforms. Here's your table about real-time. Perfect. Oh, we need information about our most popular features. Wow, let me go do this work. Hey, we need information about users. Well, you do all this work to do users. So you do all these 3 times of work for. Well, if I think about it, somebody says, I need real active users. We're like, hold on. What is the knowledge behind this, right? Okay, there's users. Okay, there's users. Those users have activities. What are those activities consist of? Oh, okay, there's all these features that they're doing. Which are the ones that we're considering that are the ones, right? Let's go talk. So you think about what are you modeling? You're modeling then, oh, there is a concept of a user. A user has some sort of activity. The activities correspond to some sort of thing, some features that are being used. So the model there is a user has an activity, and activity consists of some sort of features that they're doing. If I have that model, now my query or my metric or whatever about real active users is a query over that model, right? I'm basically joining activity with users to find my real active users. If somebody wants information about users, there's my user data around it. If somebody wants to know information about the most popular features, regardless of the users, they can go query and join the activity with the features data right there. So I did an extra work, and then with that one work and one model, I was able to answer multiple questions. So the point is that thinking about modeling, thinking about knowledge, thinking about the semantics is a way for scale and reuse. And scaling is about being resilient. And I think we're focused so much on being efficient that we don't have that rigor anymore, and that we're not scaling, not from a physical perspective, but we're not scaling from a social perspective. Then at the end of the day, not economically either, right? At the end of the day, you can do data work for the known use cases of today, but you really want to be able to go do data and knowledge work for the known use cases of today, and also the unknown use cases of tomorrow. And I think that's the hard part. But how can you quote unquote predict this? You understand how the business works. You understand how the market works. You're talking to those people. All right, I ranted for a lot, so you guys go.
No, that was a nice rant. I mean, let me ask another question here. I mean, how do we, in data specifically, and maybe more broadly in the business world, how do we balance efficiency and resilience? How do we decide where the line of priority is between those two?
That's incentivized from the leadership, from the executive.
Okay.
I mean, that's it. We live in a capitalist society. We need to go make more money. How are we going to go make money, save money? How is the organization saying, what we need, if these are our goals, and these are our kind of our operational goals of our company, if in every single department, they're like, well, this is what I'm doing to make sure that we achieve these goals, right? So, again, that's why you have to be accountable for this. So I'll give you an example. This is one of my favorite examples from one of our customers. Let me talk about this. There's a company called Prologis. Prologis is a large kind of real estate logistics company. I mean, if you buy anything on Amazon, 80% chance it goes to a Prologis warehouse. They have their mandate from the CEO was, we need to have better data quality. I'm like, okay, that's a CEO mandate. You know how they incentivize this? They said 20% of everybody's bonus is tied to data quality. You are, wow. You're engineer. You are boots on the ground in a warehouse. 20% of your bonus that goes into your pocket is tied to data quality. Now, okay, how do they enforce this? Whatever. Well, they came up with very specific business use cases. For example, what is the height of a warehouse? If I don't have the correct height of the warehouse, what happens? I may be leaving money on the table. Somebody's going in saying, why is this warehouse kind of empty? We could have stacked more things in here. We could have sold more stuff. Or why do I have a truckload of stuff that should be entered in this warehouse, but the warehouse is full? Now we got to go figure that stuff out, and we're liable for these things. Well, you got the wrong warehouse height. So if I have the wrong height, I may be leaving money on the table, or I may be losing money around this stuff. And so that's how I'm tying directly to money, right? some issue about data. So they identified a bunch of issues like this, kind of low-hanging fruit about what to do with data quality. Now, their goal wasn't to go solve these problems so they can make money, because that's the efficient thing. The resilient thing was, we need to have a cultural change and people start caring about this. Hey, we need to have the right data, because if we don't have the right data, we can have issues about how the company's processing. Now, to get into more of the semantics and the contracts part, you should say, well, this is not just about, oh, this column shouldn't be null. It's like, what does a height mean? Well, all warehouses have height. So therefore, if there's a null value, it means that that value exists. Somebody must know it. We just don't have it in the system. Let's go figure out what that is. That's what that null means. Second, the heights of a warehouse are between 15 feet and 50 feet. That's a contract right there. You can't have heights. If somebody decided, I'm just going to fill in some number there just to say it's complete, and if they put in 90, you get a flag in error right there. You can take it to the next level, and they know that, hey, warehouses after the 90s, they changed. So height was between 15 and 35 feet. After the 90s, or regulation, they changed to 50. You can get into very specific types of stuff in there. So, but this is leadership realizing that we can tie the data work all the way to your bottom line and operational goals within a company. That's what we need. And this is executive CEO leadership, and also kind of everybody throughout the entire hierarchy within an organization.
That's interesting. I've been working on a. Can you hear me? Okay.
Yeah.
Okay. Good. Sorry, I bumped my mic and the audio went out. So.
I got it. Okay.
Yeah. I was like, oh, I wonder if anyone can hear. Well, you can. It's great. So yeah, I mean, and I was writing about this morning. Actually finishing up an article for my Substack, which will be debuting this weekend. But it centers on the two questions that I've seen pop up over and over in my data career. And it's do I believe the data, and do I get any value out of it? I mean, these are two central questions, at least that I've seen pop up over and over again. But I guess the first one is like, how, but these are questions that executives would ask. These are questions that individual contributors would ask, and probably everyone in between. And the thing I keep coming back to is, you give an example of, Prologic's, incentivizing teams, or their comp is tied to data quality. But for companies that don't do this, I guess, how do you convince leadership to, I guess, first care, and then second make the investment? Because I think this seems to be one of the central themes that I've seen, where the data is seen as, usually a nice to have, but at the end of the day, in a lot of companies that don't care, then it ends up, these companies end up doing gut-driven decision making, and data is more seen as a convenience. But I think, to your point, data can drive a lot of value. But again, for several decades now, this has been the case, where data has been sort of shoot off, and how can we do better in this way? Because I think this is sort of the precursor to getting data modeling more front and center, in an activity that people are going to care about. So if data is not seen as something that's useful, then obviously nobody really cares, and there we are. So,
well, I mean, I don't. So what do you argue? What do you really say? People don't think, or they're leaders who think that data is not useful?
I think that's true. Yeah, I've seen a lot of leaders question this. Like, I invest in a data team, I'm not seeing any results. Why do we do this?
Oh, so if that's the case, I'm investing in the data teams. Guess what? So I think you have the wrong leadership in your data team, and I think that's the issue for me. And I think
so that's one thread of it, and I'll talk about the other in a second. But go on.
So on that thread is that you just have the teams who are just focusing on the technical side, who do not understand the business. So if you bring in a data team and their leader, like, go educate their leader on how the business works. I mean, this is what I'm calling business literacy, right? Mm-hmm. So make sure that they have all the context and be curious about it, right? And I think they also have to be accountable give some accountability for it, right? So actually, I wrote this post actually this morning with, I have this LinkedIn page with Mohammed Asr called Data and Knowledge Therapy Session. And we wrote this thing about ROI of teams, and you have to have some sort of a model for these data teams to go provide ROI about it. The first one is you're a services bureau. You're like a consulting company. You have bodies, right? So you have a chargeback model. That's the type of stuff like that. That's one way of thinking about ROI for this. So that's one of them. Another one is that you focus specifically on providing solutions, right? You're focusing on the business problem, your solution. So technology is not the front and center. It's more about, what are the problems I'm solving? And I know the problem I'm solving is that our warehouses are empty. and they should be full. That's the problem that we're solving. By the way, it happens to have some data quality, but that's not the first thing. So I think that's another approach about it. A third approach is that you are doing the whole the kind of the data foundations. We are setting up the technology so other people can go reuse it. But for that, you need to be tightly connected with business leaders who are saying, I need to go accomplish this task because it's going to make me money, save me money, this is my accountability, my OKRs or whatever. And you come in, you convince your peers saying, okay, I can go help you solve that problem. We need A, B, C, D to go solve it. And your accountability is basically making sure that your business line partner is being successful there. A fourth approach is about you're doing the data culture, the kind of democratizing data. So you're making sure that people have access to the data, that they have self-service tools. You're setting this up, and what is your metric there? Is how many people are actually part of the community? How many people are actually searching for data? How many people are inside my data catalog? And what are my goals of growth for that stuff? And then you can actually go start surveying, interviewing the people, saying, "Hey, we've created this whole ecosystem of a data community. What's the value that you're getting out of it?" And now you can almost do a qualitative analysis over that. So I think those are 4 different types of ROI kind of models for your data teams. This isn't rocket science. I mean, this is just basic business of how to go do this. And that's what I'm saying. That if you're going off and like, I don't know how to provide ROI, I don't know how to provide value, then I'm sorry, you're setting up your team for failure.
Well, I would say that person in charge of the data team has also been set up for failure in a lot of cases. I think this is what we've seen, where and I think Val actually had a good point here. In a lot of cases, the problem is the leader. I'm talking about the executive, maybe the CEO, is often so well versed in the business, knows all the ins and outs. So convincing him or her of the data is of using data is a big challenge. The business is doing okay. I know this is something Matt and I've seen countless times, right? Where companies making a lot of money, and it's like, well, why do we need this? We're doing just fine.
And it cuts both ways. Let's be fair, right?
Yeah.
Like I've also seen CEOs get burned, like really big, back in the big data era, these really expensive projects that really just didn't deliver much value. It's like, okay, what are you guys doing down here in the basement? Like you're experimenting.
I think the other thing is the type of leadership, right? Are you an efficient leader, or are you a resilient leader? Think about resilience. And then you go back, CDOs only last 2 years and whatever. It's like, well, yeah, they're being motivated. They're being incentivized to be efficient. I'm going to set up this thing. I'm going to run and go somewhere else. And then you jump and you go get a 10% raise somewhere else. Well, why wouldn't I go do that? You can't accomplish you can't really show resiliency and go show these things in 2 years. You're not being incentivized to go do that. I remember I was at the MIT CDO IQ conference, and it was the CDO of Scotiabank. And there was a whole panel about this. And she said, well, what can you do? And she said, just stay, don't leave. Simple. You're not, maybe the issue is that you may not be incentivized to go stay, but one way for you to go kind of showcase everything you want to go do is do not leave. But again, it's all about the incentives that are being provided to all types of leaders.
Yeah, that's interesting. Well, let's bring it back to honest no BS data modeling real quick. So we say that we live in this world where we have executive leadership is on board with data. We got a great, data team leadership is top notch. They're getting started with data modeling. How would you recommend they get started with it?
So one of the things here's an experiment that I'm trying to kind of test with some organizations is start with having this data knowledge therapist, who will probably even go report to the CEO. And that person is in charge of talking to all VPs and asking them, what keeps you up at night? Start cataloging these questions that the executive leadership is keeping them up at night. And then actually start aligning them. Like, are the things that are keeping them up at night, how are they aligned or not with the operational goals of the company right now? I think that's one thing. Because again, all this has to be lined up to value for the company.
Well, let's take a step back. How do you assess the operational goals of the company? Who sets that?
The CEO, the executive team.
Okay.
Right. I mean, my company has operational goals that is set up by the executive team, and they present it to the leadership team saying, you got to go do that. I mean, that's why you have a CEO. I don't know, but it seems surprising to you.
No, it's not surprising at all. I think you're assuming that every company operates like that.
That's a fair point. Yeah.
Yeah. That's where I was like, okay, that's not every company we've seen, but okay,
Okay.
go on.
Yeah.
So, but then if your company's not even set up like that, then you're not setting yourself up for success, right? So then I think there are bigger problems that we could talk about than about data modeling. So fair assumption is that you have your operational goals within your company, right? You're driving this. You know what your North Star is, and then go ask the leadership what keeps them up at night, and from there you can start seeing, okay, here are the topics that people are talking about. Literally, here are the words that they're using, right? Oh, the customer thing, or the orders, or whatever, right? So from there you start identifying what are the main topics that people are thinking about. So now you kind of focused on something, and now you realize, hey, as a data team, you're like, who has the most to win here? Who really needs a lot of help that they can show them kind of some growth or stuff, and then find that team who is aligned with those topics that are really important right now, and then from there just start those modeling sessions. I'm saying like, hey, how do you describe your business, right? And then you're saying that this is the stuff that keeps you up at night. Now, something which is critical in all types of data modeling methodology is to have competency questions. So these competency questions should be basically the business questions that folks need to go answer. And what you need to be able to go do is that your data model should be able to go represent all those business questions that you have, that people are asking right there. Should be able to go represent that. Now, part of knowing the business is you saying, okay, these are the questions that you have right now. Let's go think about possible questions that may happen tomorrow. Try to get into the unknowns and figure out how either the model already supports it or how the model can easily be extended to support that. So that's my first step of how to go do that. Let me pause there. What do you guys think?
Well, let me ask you this. So how do you involve the teams that are providing you the data? And so, and I'll take it a step further. If I'm a software engineer, for example, I'm making an app. No, this isn't analytics related, but say a data team might rely on the data that I produced through this app. How would I, as a software engineer, want to think about modeling my data so downstream users would get the most benefit?
So I think there's two things to think about it. One is kind of if in a legacy scenario where this already exists, or kind of like going forward. One example, I'm working with a financial customer about this. They think about telephone numbers. So first of all, like we need to store information about customers and their telephone numbers, right? Well, guess what? I mean, there's going to be a lot of different apps. We're going to go have something about telephone numbers. So this is something that we want to be able to come model and make sure that is reusable by other teams, because there's no need to go redefine what a telephone number is. And by the way, what is a telephone number? So let's go through a quick modeling exercise here, right? So telephone number, right? It's a string, right? It has it has a particular type of syntax, right? To do things. You can then break it up saying, well, it has a country code, it has an area code, it has kind of the numbers, right? It may have an extension. It says type. What types do we store here? Oh, home phone number, mobile phone number, work phone number. Do we call it mobile? Do we call it cell? Right? These are the words. By the way, what other things do we need to about this? So you start talking to, well, we need to be able to keep track of permissioning. If this is if it's a home phone number, whatever, all home phone numbers, you can leave voicemail. Can I leave a voicemail or not? There's permission around these things. What about text messages? There's TCPA compliance. Oh, so a phone number that is a mobile phone number must have a compliance around sending the text messages. Home phone numbers don't have that. So you start defining these. That's a contract, right? This is your model, your semantics around that. So then you start creating, and by the way, why is phone numbers a really important thing? Because for our organization, we have our goal that we want to reduce the amount of time we're going to spend on customer service. So we need to be able to go call them immediately, and we don't want to have bad phone numbers, right? That is one of our operational goals. That's why phone numbers is so important. And we've had so many fines on GDPR, so we need to reduce our fines for GDPR. So phone numbers are really important that we need to keep track of and have better governance around that. That's why I'm focusing on phone numbers, for example. So we model that, and this may be a centralized thing that people are doing because it's an operational goal of the company. We're modeling phone numbers, and this is the right way that we're going to go do this. And then a team comes in and says, "I'm going to create an app about that is going to keep phone numbers." Hey, go use a phone number model. It's there for you. Oh, you want a SQL DDL for it? You want a JSON schema, an Avro schema? There, just now you get the syntax of what that stuff represents. So that's how you would go deal with in situations of like, oh, I'm just starting kind of new types of creating new apps around that. What do you think?
I really like this, again, business-oriented process toward data. I mean, I think what often happens is a new developer is just handed the task of like collecting phone number data. And they obviously aren't thinking about these things. It's just treated as like an isolated feature, not as a mission critical like data collection task.
No, we're talking with some engineers about this last
Yeah.
week, Matt. You know, because we're talking about software architecture, so not data related, but data is usually on the receiving end of anything that software does. And so it was interesting because we were talking about ORM specifically, object relational mappers, and how this person was using MongoDB with Mongoose, which sounds hellish. I've actually done that before, but trying to join all these Mongo collections together. But the ORM sort of had this relational slant to it, so it like relational-ish joining of these. But then this, you can imagine the data quality, because as a software engineer, they're just like, okay, a phone number, that's that could be anything. That could even be an n number digit for all I care, depending on how I want to store it.
Yeah.
Right. And this is where it gets bananas. But what we often find is data teams are on the receiving end of a lot of this data. So, but oftentimes there may or may not be communication between, the people creating the data and the people using it. So,
and I think this goes back to why it's such a the art and the science, right? Because you can think of how people are storing phone numbers. Right. Well, I can put a table, and the table is called phone number, and that's it. Okay. How did I know if that was a mobile phone number? So, or I could have a column called mobile phone number, cell phone number, right? All these different things. But then if I have a null in there, if I have a null for a mobile phone number, what does that null mean? Does it mean that they do not have one? Does it mean that they have one, but they didn't give it to me? Does it mean that there's a bug in the data and we didn't capture it? I don't know, right? This is the semantic stuff. So one of the cool exercises I like to go through with people is there's this famous paper. Well, not one of my favorite papers, right, from like back in the early 90s, and it's a proof, basically a proof by example that data integration is really complicated. And you need higher order logic. You can't do this in first order logic. It means that you can't always do it in SQL. And the example is, how do you model stocks? So you're saying the company, the closing price, and the closing date. So I'm going to have these three types of data. So what do you do? One first approach, or who wants to go first? One way of modeling that in relational form, tables. And for anybody live there, who wants to give an example, right? So you're modeling company, the closing price, and the closing date.
What's the use case for analytics for transactions?
Okay, you see, I'm glad you bring this up. Right?
Yeah, there we go.
Very good. You see, yes, the use case is asking, right? But let's kind of to continue the example. Let's forget, like, what are three possible?
So let's talk about a conceptual model first, right?
What are possible ways of doing this?
Yeah, that's really interesting. I mean, you can have a number of ways of doing it, frankly. The notion of a company, if you're talking conceptually, what is a company? So what are the attributes of a company? And then a company might have stock. So there's a relationship of a company to its stock, right? And there's some notion of a price and then dates as well, transactions, also who bought the stock, who sold the stock, and any number of things, right? Who's the brokerage? And
so
keep going on.
Let's keep it very simple here. So let's say for a stock, let's consider I have one table called stocks, and I have a column called company, a column called price, a column called date. Right? It's kind of one way. So it's a stocks table, right? Another approach is to say, every company is a table. So there is the IBM table, there is the Microsoft table, there's the Apple table, and it has a column called price and a column called date. Valid too, to go store. I can store that data. Another approach is to have a table called stocks, but every single column is the company name. And what I have then is every row is the date and all the closing prices for every single column, for every single company, all in one row. Now you can argue there's different. Why would you want to go store this physically this way? Well, hey, if my queries if I have a query workload that says I need to return all the stocks for a particular company, then storing it by company in a table is great. I just scan the whole table, right? If I have a requirement where I need to very quickly be able to go get all the closing prices for every single company in a particular date, that's why I want to have all the company names as columns, because I can just do an index on the date and just return everything. Now, kind of the normalized way is doing it is saying I want all the stocks where you have a column called stock, closing price, and closing date. So an interesting observation about this is that if you look at a company name shows up as a table name, it shows up as a column name, and it shows up as a value inside of the table. So now when you're looking for this, like if you're trying to go integrate things about data, about company names, you're trying to go integrate data that I need to go combine, hey, I need to join the name of this table with this value of this column called company name, right? That's stuff you can't do in SQL itself, right? Now you have to go turn that metadata into data itself and go do that. But anyway, all this to say is like, these are different ways of modeling this type of stuff. And given a particular context and use case, there's a quote unquote wrong way, but for another one, it was the right way. Hence the art and the science around here. So this is a really cute example that I like, just the proof by example that you need higher order logic to be able to go integrate data when it comes to doing transforms.
For sure. Yeah, and it's interesting too. I mean, somebody was asking the other day about books and conceptual data modeling. So if the audience knows of any good ones out there, let me know. But I've been spending a lot of time thinking about this too. Like, so you asked the question that you just asked. Okay, so like, how at the highest level do you represent that concept, right? Then how do you start breaking it down to a model that's coherent? But it's interesting because this doesn't live in a vacuum, right? So there's always a use case. If I were just to model things on its own, I mean, I can do that, but it's what are you trying to do with this? I guess at the end of the day is one question that I would caveat, because I've looked at some conceptual modeling, actually quite a few examples of this, and from various leaders. Steve Hoberman's the last person I read, and he does a fantastic job describing it. But unless you understand the context in which you're trying to model, it gets a bit tricky. So at least in my opinion, I don't know if you have thoughts about that.
Yeah, it gets tricky because you don't know when to stop, and then that's why you end up boiling the ocean.
Exactly.
This is the big thing. So that's why, and then even the use case itself is not enough, right? And that's why you need to go have what we call competency questions. And I mean, this is something very well thought out kind of in the late 90s. So all the work on knowledge acquisition that happens, and all the work on ontology engineering, there are all the books around this stuff, right? And I think the issue is that the language that's being used there, we don't relate to that language today, right? But the principles are still the same. And I think, so there is definitely, we need to be able to upgrade that language and kind of those principles to the kind of the technology of today. So I'm really happy, Joe, that what you're doing for your book. And I've been actually having some conversations with some professors around like, what is the knowledge engineering book that we should be using today? More from I think the low hanging fruit is, let's go take the main type of papers that people sort of look at today and kind of upgrade that language. And that's probably kind of a graduate school textbook. And then from there, I'm trying to go work on getting people to say what would be an undergraduate textbook when it comes to knowledge, data knowledge modeling. I think there's a lot of space opportunity here, and we really, really need this.
For sure. It was Jessica Talisman was on our show a couple weeks ago. Her background's in taxonomies and library science and whatnot. I feel like I'm starting to, the more I start thinking about it, I think library science is one of these areas where I hope that there's a lot more linkage, with the data community. I think there's,
for sure.
In fact, when I was in Australia about a month ago, somebody asked, who should I get to do like data quality and stuff that sounded like, the more they start talking about this again, that sounds like a library science question. Or maybe you should, because should I have my data engineer do this? Like, absolutely not. This is like definitely not the person you should have doing this. They're not trained in it. But yeah, it's an area I've been personally exploring a lot, is sort of the linkage between just the fields of library science and traditional data that kind of, I come from. I'm not a library scientist. I'm not going to profess to be one. But even when I talked with Bill Inman about the idea for this book, he's like, you just be sure and talk about taxonomies and ontologies at a minimum. You have to.
Yeah. So I mean, I got the books. I got a bunch of books here with me. So please take a look at my book.
I'll buy your book.
Here's the other one. Semantic Web for the Working Ontologist. This is another classic. It's main about RDF and stuff, but it's about all the principles behind the ontologies that I would highly recommend. So
nice.
these are the two books I recommend on this space. And then heck, if you look at just fact tables, dimensions, the dimensions are taxonomies. What you're doing, right?
Yep.
That's it. And the thing is that those taxonomies should be shared, right? There are things that are shared agreements around this. You should have on the show Katarina Kari. She works at IKEA, and she was doing a lot of the knowledge graph work at Zalando. and now she's at IKEA. You should definitely have her because she's
make an intro. Love
yes,
to
I'll definitely do it. I'm just clicking some here about that. But yeah, I think, I mean, if there's one thing I want people to remember, there's so many things. If there's one is data needs to move with the semantics. Today, data moves by itself, and we need data to move with semantics tied to each other. So when a system perceives that, it knows what it means, what to go do with that. And that semantics starts with basic modeling of what this stuff is, and then it can get more expressive with the contracts and stuff, and then it can get even more expressive if you're pointing to a particular product or color or whatever. I'm like, oh, I know exactly what that means because it's part of our taxonomy that we're using. So I think that's one of the key things. And then I know because we're running out of time here, my rule of thumb when it comes to modeling is one of the big things is this thing an entity or should this be an attribute? That's one of the things that happens all the time. If you are going to say a lot of things about it, and you think that other people want to go say a lot of things about that thing that you're considering, you're debating, that should be an entity, right? So if you think about a telephone number, a country code. Should a country code be its own thing? So I model a telephone number has a country code. Depends. If you're going to say a lot of things about the country code, then maybe you should. If you're not, then probably it's just an attribute of the telephone number. So that's one thing. And second, think about identifiers. Modeling goes hand in hand. Every single entity has to have an identifier, a way to uniquely identify that thing. And think about what is that identifier and how is that identifier going to transcend time? You want how is that? We do this for the web, right? This is why the whole semantic web is because you have URLs, HTTP URIs is how we use identifiers, and you want to have a URL on your website that stays for a long time because you want to point to it, you want to refer to it all the time. Think about it that way. And so I always think that the web architecture is the fundamental example of how to do a distributed information space, a distributed heterogeneous information where anybody can say anything about anything.
Right. Awesome. Juan, thanks for your time. And thanks for the great conversation. I think the audience definitely enjoyed it. I know Matt and I did. For people who want to learn more about you, how can they do that?
You can just find me on LinkedIn, Juan Sequeda, and listen to our podcast too. Cataloging Cocktails every Wednesday at 4 p.m. Central. We do it live. And then hits the podcast on Thursdays.
Great podcast, by the way. So
and there are actual cocktails there. The next time we're on, we'll have to actually imbibe some ourselves. So,
so a couple of things. I actually just realized I was told this morning I need to fly to Munich. I'm going to be in Munich next week. In case there's anybody around here, next Monday and Tuesday in a week, I'll be in Munich. So any data folks out there, let me know. And then we're going to do live cataloging cocktails at the DGIQ conference in Washington, D.C. So we're the closing event on Wednesday. We're doing it live. So if anybody in Washington, D.C., just ping me because we're going to have a live show giving cocktails to everybody. And then we'll have kind of a nice happy hour afterwards.
Events. Speaking of events, so this week, if you're in Utah, I'm going to be speaking at the Big Mountain Data Conference, talking about data engineering. What else is going on here? I feel like there's a if you happen to be at UVU, what's that, Utah Valley University or something, I'll be speaking there on Wednesday night. And there's Data Driven NYC tomorrow. You can go catch Matt there.
I'll just be hanging out. I will not be speaking.
We will not be speaking there. He spoke last month. It'd be kind of weird if he spoke 2 months in a row. But yeah, go have Matt's autograph your book. And then next week on the Monday Morning Data Chat, we have Jeremiah Lowen, the founder and CEO of Prefect. And the week after that, we have Sanjeev Mohan, who's he's G. I love this guy. So
Sanjeev I love Sanjeev.
Yeah, he's cool. Then I think on the week of the 28th, it might just be Matt and I doing a show. God, it's funny. We used to just do these shows, the both of us all the time, and now we have
back
guests.
In the early days, right? We just got started. I remember broadcasting from like a backyard one time, like several times actually.
Yeah, that's how Tim Gasper and I started out like that too. I think the first 20 episodes of Catalog Cocktail was just the two of us. Just
fun.
And then we had a couple of guests, and we're like, when we looked at the numbers, like, hey, we're doing good, but we had more guests. Like the numbers increased. So then,
do you miss doing podcasts with each other?
I hesitate because like we talk a lot anyways. So I'm like, all our conversations are like our podcast.
Same with Matt and I. Yeah.
That's how we get started.
Like, But no, I do. I think I just miss is going more to the conferences and having those hallway conversations that you're just chatting together, blah, and then you go to have a drink or go dinner, and then this keeps going. So that's that live podcast type of stuff that I really miss.
It's so much fun. So, and I forgot to mention too, Utah Data Engineering Meetup. We have a surprise guest next Wednesday. Zhamak Dagani is going to be speaking at our lowly meetup, and so, but it won't be the talk you expect about data mesh. It's data mesh, the hard part. It's targeted towards engineers and very technical people. So if you have questions about data mesh from a highly technical angle, be sure to show up next Wednesday, the 16th. Hit me up for details. Cool. Anyway, always fun to chat with you, Juan.
Likewise.
So we have to do this over a beer in person sometime. So
yes,
yes,
for sure.
We'll do that soon.
Yeah.
Awesome. Okay, cool. Thanks to the audience. See you next week. Bye bye.